Okay, guys, I just wanted to touch base real quick and explain a couple of things. When it comes to Newton's second law of motion, it is important that you always draw a free body diagram. So, if you have the force of gravity down on an object and the normal force up, try to draw your arrows so that they are proportional. So, I guess the way I drew this, my normal force is larger than my force of gravity. So, I would have an overall net force that is in the upward direction. Every time you're drawing a free body diagram, you draw an original diagram with all the forces and then a net force diagram. If the net force is zero, so for example, if you have force of gravity down, normal force up, the same size, the net force is zero, 0 newtons. But if not, it is some other value. That some other value is always equal to mass times acceleration. So when you're writing an equation for each one of these, over here on the right side, and they're going to show you this in the video, you're still writing F net equals force of gravity minus force normal because they're opposite each other. It could be force normal minus force of gravity, doesn't matter because it just doesn't matter. In this particular one over here, you're still going to write F net, but you're always going to write the bigger one minus the smaller one. So force normal minus force of gravity would have to be the way that one is. Now over here, our net force is zero. So force of gravity equals minus force normal. So I just gave away what that was. Force of gravity is equal to normal force. But over here, normal force and force of gravity are not equal to each other because net force has to be equal to mass times acceleration. Anytime you see F net, you write MA, and then you replace your other ones with values that you have if you have them. Remember also that force of gravity is equal to weight. So if they're talking about the weight of an object, they're talking about the force of gravity, which is equal to mass times gravity. If I go up here, there's one other thing I wanted to explain to you, and that is terminal velocity. This is kind of an example of somebody skydiving. When you're skydiving and you first jump out of the plane, all you have happening is your force due to gravity downward, which is mass times gravity. When you go through some of the air, that produces this force of air resistance, or what's called a drag force, frictional force. But if the drag force is less than your force of gravity, then you still have an overall net force downward, F net. So you're accelerating downward. Here, obviously, we have an overall net force downward because there's no other force opposing it. However, when we get to a point where we've fallen through enough air that our drag force and our force of gravity is equal to each other and we have a net force equal to zero, we've reached what's called terminal velocity, where we are no longer accelerating because our net force, which is ma, is equal to zero. So we have zero acceleration because obviously our mass isn't zero. We have reached a velocity that is constant velocity. Oops, that's wrong, but you know what I meant. So there's a couple of circumstances. When you have an overall net force equal to zero, you can be sitting still. You can have a velocity that's equal to zero, velocity equals zero, or you can have a velocity equal to some number, but it's just constant. That constant can be zero, of course. When you have a net force that is equal to something different, the velocity is not constant. There is acceleration happening. And oftentimes the problem asks you to find that acceleration. Okay, so you'll go back up here and you'll complete all of these and turn it in tonight.